Here we will begin the shortest domain of the SAT and the final domain that we will be covering, which is some geometry and trigonometry. There won't be a lot of questions on geometry and trigonometry on the SAT, but in my personal opinion, the ones that do show up, if you have a good basic understanding of some of these concepts, are among the easiest questions that you could get on the SAT, but also among the list of ones that are most missed due to the limited exposure to some of these concepts. By the time most students have taken Algebra 2, it's been a while since geometry, and not all students take pre-calculus and trigonometry. And so it's good to kind of review some of these skills before we get into the SAT. So take some time to look over some of these definitions and terms, and then I'm going to talk about these terms in the context of these different diagrams that we have. So one of the conventions that you'll see within geometry and trigonometry is the convention of congruency within angles and triangles, as well as similarity. And so here we have two triangles labeled A, B, and C, X, Y, and Z. And we have these little markings here where we see that it's a single arch, a double arch, and a triple arch. That means that these angles are congruent in size, meaning they're the same measure. And this leads into a fact that we have about triangles. If I have two triangles with congruent angles, then they're what we call similar triangles. I can scale up the size or scale down the size of a triangle, and as long as I scale all the sides proportionally, the measure of the angles do not change. For example, this triangle ABC, if I wanted to scale up the length of this side AB, and also scale up the length of side AC, this gives me a new triangle in which all three of these angles are congruent from the original triangle that I had, even though the side lengths are much longer. And so that's what I mean by proportionally scaling these sides. And so we end up with a similar triangle. And using that along with some other tools, we're able to analyze and solve for different parts of various geometric figures. If we're talking about side lengths being congruent, we use tick marks on the side to indicate congruent side lengths. Next, we're going to look at a few different diagrams. Here we have three intersecting lines, and these lines have angles measured X, Y, and Z. Well, when we have two lines that intersect, like we have here, angles that are opposite each other are what we call vertical angles. And vertical angles are congruent in measure. And so if this is angle X on the right, then this is also angle X on the left. The same is true for angle Y up here and angle Z down here. Another relationship we have with intersecting lines is that angles that are adjacent to each other, such as these two here, are supplementary to each other, meaning that they have to add up to 180 degrees. That means the measure of this angle has to be 180 degrees less the angle X. Same as this angle down here is 180 less X degrees. These angles up here have to be 180 less Y degrees and 180 minus Z degrees for these two angles down here. We also have this concept of transversals. When we have two parallel lines, so this line here, as well as this line here, those are drawn poorly, let me just highlight them. This line here are parallel. And then any line that intersects both of those is called a transversal. And we have these special relationships within transversals. We have these things called alternate interior angles, where they are on opposite sides of the transversal, but they are inside of the parallel lines. Alternate interior. Those angles would be congruent in measure, as we see labeled here. We have a second transversal drawn on this diagram, giving us two more alternate interior angles here. And then if we also want to look on the other side of the transversal, this angle and this angle are congruent to each other, and they are also a supplementary relationship, 180 minus Z and 180 minus Z, in order to give me those two angles. We also see that we have vertical angles present here and another supplementary relationship, 180 minus y. The other angle relationship we have with transversals, let me extend this line a little bit, is our alternate exterior angles. And again, those are going to be opposite sides of the transversal, but they're going to be outside of the parallel lines. And those are going to be congruent as well. And we can also see the vertical angle relationships here as well, and here and here. We also have similar triangles placed inside of each other. And so here we have a smaller triangle inside of a much larger triangle. Well, when we have one triangle placed inside the other like this, we have similar triangles. And when we have similar triangles, these corresponding angles are going to be congruent. So we see how we have x and z being the congruent angles. The other things about triangles is that all of the measures inside of a triangle of the angles have to add up to 180 degrees. With these facts combined, we're able to simplify and evaluate different diagrams and solve for missing values. So we'll go ahead and do that now. Missing angle measures. Here we're given a diagram. We have angle A, B, and C. Well, we can start with the measure of angle A. It is inside of a triangle and two other angles are given. So since we have the triangle's interior angles, well, the sum of angle A plus 60 plus 75 has to equal 180 degrees. And if we solve for A, we find out that A is 45 degrees. Then we can look at angle B. Well, here we have vertical angles. And vertical angles are congruent. Therefore, B has to equal 60 degrees. And then the relationship between C and 75 is supplementary. And supplementary angles have to add up to 180 degrees. Therefore, the measure of angle C is 105. Here we're given transversals. And so we can look and see, well, first we start with angle A. We have alternate interior angles. Alternate angles are congruent, so A is 73 degrees. Then we can look at B. We've got the interior triangle angles again, so we know that A plus B plus 45 has to equal 180. Well, we already know that A is 73, so we can solve for B, and we get 62. Last but not least, A and C are supplementary. So A plus C has to equal 180 degrees. Again, we know A already is 73, therefore C is 107. Lastly, we've got our similar triangles, one inscribed inside the other, and we're told that L and M are parallel, and that's how we know that they're going to be similar. So here, what we know then, if these are two similar triangles, we've got the smaller one here and the larger one here, we know that these two angles are going to be congruent, so the measure of this angle is Z. We also know that these two angles are going to be congruent, and so that's going to be the measure of X. And so we can use either triangle to consider this problem. Y is 30 degrees, Z is 45 degrees, therefore X plus Y plus Z has to equal the sum of the interior angles. That leaves us X with a value of 105.